Alright, hello once again. This is Jeff Scott of Rankin Technical College. I've been going through a series of video presentations that I'm creating based off the two textbooks for the Rankin Technical College AWD, or Application and Web Development 1000 Web Development Technologies class. I've already gone through more than 20 presentations for the 20 chapters that are in Muroc's HTML5 and CSS3 4th edition. I'm now into the second book for the course, which is Muroc's JavaScript and jQuery 3rd edition. So far I've gone through the first 4 chapters that you see on your screen, and right now I'm going to go over Chapter 5, which is on how to test and debug a JavaScript application. Alright, so what do we talk about in here? How to do test plans. Let's even be more basic than that. We'll talk about the kind of errors that you can get in a JavaScript application, or usually any kind of application. How to use top-down coding, how to use the Chrome developer tools, how to trace an application with console.log statements, how to view the source code of a web page, and how to validate the HTML and the CSS for a web page. Talk about why you test and why you debug, what a syntax error is, a runtime and logic error, why you create a test plan, types of bugs that can occur and how you fix them. Okay, so this may sound really simplistic, but it bears repeating. When you are testing your code, you're trying to find every error you can. You should always consider when you go through your own code and you find errors that you made, hopefully unintentionally, you should consider that a positive. Better you find your errors before you put something live and have end users find the errors. Okay? Once you find your errors, you want to fix them. That's the process of debugging. So there's 3 kinds of errors. There are syntax errors, which means they're errors in the rules of the language. If I'm going to use a JavaScript alert statement, I type in alert, A-L-E-R-T, then in parentheses what I want to put up on the screen. Well, let's suppose I fat finger, and instead of spelling it A-L-E-R-T, I spell it A-L-R-T. I leave the E off. I'll get a syntax error. All right, a runtime error occurs when the program is running. The code appears to be correct, but you can't really test it per se until your code is running. And a logic error, those are the hardest ones to find. What we all think of ourselves as programmers, regardless of the experience level, is the more you program, the more you feel that you're an expert. And you won't make logic errors, because it's an example of a logic error is adding 2 values together when you mean to do a subtract. All right. So here's the future value with a logic error. Okay, so if I'm saving $10,000 at 7.5% for 10 years, I'm almost doubling what I have. All right. So when you get these kinds of syntax errors, what should you look for? Misspelling words, or putting the wrong capitalization in, omitting parentheses when they're required, omitting quotation marks, single or double, where they're required, omitting braces where they're required, starting with a double quote, ending with a single quote, forgetting a semicolon. Capitalization and spelling errors are a big one. Referring to an attribute incorrectly. Should be saying sales tax camel case, but you say sales tax like this. Again, these are types of errors that everyone makes. Not testing to make sure a user entry is of the right data type before processing it. Not using parseInt or partfloat first to convert an answer into a numeric value before using it. Using 1 equal sign when checking for equality instead of 2. Remember, 2 is equals, 1 is assignment. I would tell you too, and you may see this in here or someplace else, Sometimes the best thing that you can do is when you run into an error is just literally walk away from the computer for 10 minutes. You know, go downstairs, have a soda, go to the bathroom, just take a walk and come back. If you're still having problems, ask a friend. Not during a test, of course, but I have no problems with students asking students for help. All right, you can have floating point problems because floating point's not an exact science. Problems with local and global variables. Okay. So here we've got invalid data. How do you handle invalid data? Well, the only way, the computer, by and large, computers don't really have a whole heck of a lot of logic in them. It's been said that the computer has basically the abilities of an 18-month-old child. And me right now with a grandchild who's about 18 and a half months, although I considered her to be very bright, she can't do a lot of things that you and I can do just because she's not old enough and she hasn't had the experience yet. When you are testing, you're going to do this in phases. First, you want to test the application with valid data. So if I'm doing a calculator, I want to make sure that if I put 7 plus 3, I get 10. 7 minus 3, I get 4. 7 times 3, I get 21. 7 divided by 3, I get 2.3333 or something like that. Then I want to test it with invalid data. So for example, if I'm writing my own calculator, what happens if I try to put in 2 decimal points? So what if I try putting in pi 3.14159, then I put in there 0.678? Program shouldn't handle it. Or should handle it by saying, giving the user a message that that's illegal, something like that. So you make test plans and you figure out exactly what you're going to test. Every time you run a program, in essence, you're testing it. All right? Common mistakes made testing. Number 1, not testing with a wide enough range of entries. Number 2, not knowing what the results should be and assuming because they look correct, they are correct. So if I was doing this future value, I might have a boatload of times where I figured it out. You can go online and just type in future value calculator and find one. So I could come up with 10 values. But then I also want to check it with negative values here, and here, and here, or missing values, or whatever, to make sure that it works as well. You can write code, really when you think about it, there's about 3 different ways that you can write error handling code. The first one is what I call the ostrich method, or the duck and cover method. And with that, you just hope that the person writing the code will never make an error. Now that doesn't really make a whole heck of a lot of sense. And that's not the way you should write code. Second, you can put in a bunch of if statements where you check everything and you don't let bad data go into the system. We'll look at that later. And third, you can use what's called exception handlers, which use a try-catch block. And again, we'll go over this stuff much later, which says I can let bad information or bad data into the system and then I'll handle it there. So as you go through this, you may start with no data validation, but you should validate everything the user puts in to make sure that indeed it looks the way that it should look. All right, Chrome. Notice that if I come through here and I bring up this is what I showed you earlier. If I hit in Chrome the F12 key, what does it have? A lot of things. All right, and when we looked at some of these when we went through the HTML stuff that's in the book. So I can look through this and I can say, okay, I can come over here and say, gee, I wonder what this would look like if I ran it on an iPhone X. And now I can see it. There is a lot of information that you can get from here. We used elements, the elements link a lot when we were doing the HTML stuff. Now we're going to end up using the console a lot. All right? And it's funny, you notice when you look in here, wow, there's mistakes. Yeah, there are mistakes on most web pages. So again, we will look at those in depth and breadth of coverage much more as we get into this in more detail. I showed you the F12. It's a toggle, so pressing F12 turns it on. Pressing F12 again turns it off. I showed you the console. We're going to be able to put our own stuff in there. All right. It's a good way to do debugging. If it still doesn't help, I can click on any of the numbers in here and set what's called a breakpoint. So I can tell the system, hey, when you get to this certain point, stop execution. And then I can step through one line at a time by hitting my F11 key. All right, there's a step over, a step out, and a resume. There are also what are called different windows in here. So I can open up or look in some of these windows to see what values my variables have. I can also log information to the console. You will see this when we get to that point because it's another way that you can debug. So here we've gone through and we're logging stuff here. So we can double check it, make sure it's working the way that we think it should be working. If you want to see some HTML in the browser, you can come over here. All right, again, bring up a web page, which I don't have. And, you know, again, we talked about this, that you can, so if I come up and bring up a web page, let's see. This one again, I can right mouse click on here. Come on. Well, I think it's because I've got this open, but I'm not sure. So I can right mouse click and choose view page source, and it shows me all the HTML that made up this page. All right. Okay, let's finish this up. How to view JavaScript code in an external file. All right. Again, you may or may not notice this. Let's see if I come through here. And there's JavaScript code. I don't know if I have access to any of this or not. There it is. So there's the code. So I can just click on the link and it'll show me the associated code. All right. Finally, sometimes the problem when you run into an error is not in your JavaScript, it's in your HTML. So you can go out to validator.w3.org and you can run the HTML validator. There's a similar one as well for CSS. And that pretty much here is it. So the next time that I come back and talk with you, we will be going over how to script the DOM with JavaScript, and how to work with links, images, and timers. Once we get done with that, we will jump into jQuery. All right? So I'll see you with that information fairly soon.